Yeah, it's okay.
This one is
Negative 0.2 microcoulomb.
negative 0.2 microcoulomb. This one is 3 microcoulomb.
Yes.
This is 0.2. Okay, now this is a positive and that's a negative charge. Am I right? Okay, now tell me, will the charge flow? Let's label this as A and B. That means I want you to get the concept first. All that I've taught you and all that, and in the event, let's say sometimes you wouldn't have learned that in the class, but we have enough knowledge to get the knowledge. Do you understand? Then refer back, fall back to your previous chemistry and all that, and tell me, will the charge flow? Would there be a flow of charges? Why?
There is, on the negative sphere, it's a low potential, and on the positive sphere, it's a high potential. So the flow of electrons goes towards the negative sphere, and therefore both spheres will reach the same potential.
Same potential. Okay. What causes flow of charges? That means, according to your explanation, what caused the flow of charges?
The different charges of the different potentials of the.
See, charges are different, potentials are different. I see that you're just mixing it up. So I am not very clear which is which. That's why you see, potential is different, electric field is different, charges are different, current are different, voltage are different, resistance is different. They all are different. So which quantity are you talking about here? What causes the flow of charges? That means what causes the flow of electrons? Now, you said there's no flow of electrons. It's absolutely correct. Because charges means flow of electrons. See, all charges are carried by electrons. So it is right, but your direction is wrong. Electrons flow from negative to positive. You said electron flow from here to there. Actually, it's from there to here. Because that's a negative level. That means E is rich in electron. This is low in electrons. So electrons will move up, so negative will slowly come down. So this will positive will slowly become more negative, eventually they will be equal. If this goes there, that will become more negative and more negative. This will be more positive and more positive, they can never be equal. Can you understand what I'm trying to say? See, a lot of things here you learn. Number one, you must remember, so what I mean by reflecting back to your learning, you could have asked yourself, what makes water flow from one point to another point? What makes water flow from the water tank to the tap below? When you turn the tap, water flows out, yes or not? What causes the flow of water? Huh? Gravity. You passed all this already. Pressure difference. The water flows from high pressure to low. That's why you put the water tank right on top. The reason why the water tank is right on top is to create the high pressure scenario. Water will never flow if there is no pressure difference. That means it is not plenty of water. You can have a small amount of water in the water tank. You can have a large amount of water here. Let's say there's another tank here, another tank there. Large amount of water, small amount of water, large amount of water, water will flow. Because that's high pressure, that's low pressure. Until the pressure is equal, not the amount of water. Now reverse it. Small amount of water, large amount of water. Can you follow? Water will still flow as long as there's high pressure, low pressure. Can you follow? But let's say you put a large amount of water here, another tank large amount of water side by side, and you put a pipe, they will not flow. Because there's no pressure difference. Water pressure difference, you need the height. Can you follow? For charges to flow, you need potential difference. That means it's nothing to do with negative charge, positive charge, how much of charge you see. The moment you see it wrongly, concept is wrong. Can you follow? It's nothing to do with the charges. It is there a potential difference? So that's the number one point you must grasp. For charges to flow, there must be a potential difference. So somewhere take down this point. I mean, the best thing is to take down the question itself. Huh? Okay? Do you understand? So the point that you should grasp is, for charges to flow, there must be a potential difference. Without potential difference, charges will not flow. The next thing you got to know, now, will the charge that is flowing, will it come to an end? The answer is yes. the charges will keep flowing until both of them achieve what? Equal potential. Equal potential. Until both of them have the same potential. Why? Which means no potential difference. Equal potential means no potential difference. Same marks means what difference? Can you follow? That's why we get equipotential. They become equipotential. Now you got the concept. Alright. Now, number 3. This is all rounding up. For those who missed this chapter, you can catch up. Number 3. The moment you have one metal sphere negatively charged, another metal sphere positively charged, there is already a potential difference. Because this is negative potential, this is, you don't need to look at the amount of charges. That means straight away there is a potential difference between the two. Let's say this is positive charge, this is also positive charge, and that's when you have to look at the amount. Is the positive charge both of them the same? 3 coulomb, 3 coulomb, and then there's no potential difference. Can you follow? But if it's a sphere, it's just not the charge. The radius also is important. Because, can you see, a lot of things to see. Because potential, electric potential on a sphere is Q over 4 pi epsilon. So both of them can have the same charge. But yet, that means they can be 3 coulomb, 3 coulomb. You see, all this they can ask you potential questions. They can give you 2 spheres and they say both of them have positive 3 coulombs. Now students say